and welcome to Agora Math Circle Senior Beginner Lecture Note video. Today we're going to look at counting. So first we'll look at counting with addition and subtraction. Next, the multiplication principle. Then casework. Then counting pairs, and finally probability. So let's start with a really simple problem. Here are a list of numbers, and the problem is going to ask us to count the amount of numbers that are in the list. So if this list started from 1 and ended in a number, it's really easy to find out how many numbers are in the list. For example, if we had a list that had numbers from 1 to 27, how many numbers are there? 27. But here, we're starting with a weird number, 9, and we're ending with 27. So what we can do, and what we usually do, is just count by ourselves. But what if we had 100 numbers, or 1,000 numbers? It's going to be much harder. So, another way we can do this is with an equation. So, given two integers a and b, with b is greater than a, b minus a plus 1 is going to give the number of values that are in the list. So you're probably wondering, how did I do that? Well, you know how I said that you might individually count the numbers that are in the list? Well, if you think about it, it makes it easier, right? Turning this to 1, then turning this to 2, turning this to 3, 4, and all the way up until we get the amount of numbers that are in the list. So why don't we just do that? We want to turn this into 1, this into 2, and keep going. So there must be a way to turn any number into 1, and then the number after that into number 2. Remember, this has to be consecutive, so it has to be like 9, 10, 11, 1, 2, 3, like that, numbers like that. So the first thing I did is I assigned the first number a variable, a, and the last variable, b, or the last number a variable, b. And then I knew that every number after that was just going to be a plus 1, and then after that a plus 1, another 1, so a plus 2. So it's going to be consecutive, so they'll go up by 1 each time. So I said the first number is going to be a, second number is going to be a plus 1, a plus 2, and you're going to keep going until you reach the last number, which is b. Then, if I want to turn this number into 1, what do I do? Well, let's look right here. If I want to turn 9 into 1, what do I do? Subtract 8, right? So technically, subtracting 8 is just subtracting 9 minus 1 from 9. So 9 minus 9 minus 1 is 1. So I did minus a minus 1, which is going to give us 1. Any number, you can try with any number, you can do with 7. Say 7, and then 7 minus 1, which is going to be 6. So 7 minus 6 is going to equal 1. And you're going to keep doing that for all of these numbers, because any number minus the number itself minus 1 is just going to equal either 1, and then if you do for this, it'll be 2, it'll be 3, and you're going to keep going until the end, where you're just going to do minus a minus 1. And when we do all this is all just going to cancel out, 1, 2, 3, all the way. Then we're just going to get b minus a minus 1, which will turn into b minus a plus 1 when you distribute the subtraction sign. So as you can see here, this part right here says that there's 1 number in the list. This part right here, ignoring all this, says there's 2. And this part says 3. And you're going to keep going until you hit the last digit, which will tell us how many numbers are in the list from there on. So now we can apply this to our actual problem. So b is going to be our last digit, which is 27. So we'll write that as 27. And then a is going to be our first digit, which is 9. So minus 9. And then you're going to add 1 because of our equation. So you add 1. And this gives us 18 plus 1, which gives us 19. So there are 19 numbers in the list, and you can check by counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So, as you can see right here. Now, if you have any problem that has a consecutive number, a list of consecutive numbers, and asks how many digits are on there, you can just use this equation without wasting time and counting. So now let's look at this next problem. At Brown High School, there are 12 players on the basketball team. All the players are taking at least one foreign language class. The school offers only Spanish and French classes. 8 of the players are taking Spanish, and 5 of the players are taking both languages. How many players are taking French? So, to find this, we need to look at the given information. So we know that the people who are taking Spanish are 8, and we know the people who are taking French and Spanish is going to be 5. So what we need to find is the people who are taking French, but not taking Spanish, so we can find the total people who are taking French. So first, you can't just add these numbers together and just get the answer. That's not how it works. Or subtract numbers and get the answer. That's not how it works. So first, what you need to find is people who are taking French but not Spanish. So to do that, you need to take the total number of players that are there and subtract the people who are taking Spanish, because those who are not taking Spanish are taking French. And it already gave us the number of people who are taking French and Spanish. So if we do 12 players minus 8 people who are doing Spanish, we get 4, which is going to be 4 people who are just taking French and not Spanish. Then, if we add that to the people who are taking French and Spanish, we get the people total taking French and taking French. So we get 5 plus 4, which equals 9. So another way you can do this is with a Venn diagram, which looks just like this. You have 2 circles and a little part where they overlap, which is a shared area. So the first thing I'm going to do is draw 5 dots for the people taking French and Spanish. And since I know that 8 people are taking Spanish, I know there's going to be only 3 in the only Spanish side, since 3 plus 5 is going to be 8 people. So 8 people are taking Spanish, and of those, 5 people are taking French and Spanish. Now we need to find whoever's left. So because we need 12 players, that means that there's only going to be 4 in this area left. 4. So if we add that up, 4 plus 5 plus 3, we get 12. And that's how you find the answer. So now let's look at the multiplication principle. And let's look at this example. You have 3 shirts and 4 pairs of pants. How many outfits consisting of 1 shirt and 1 pair of pants can you make? So there are 4 different ways you can make this. First, you can make a list and see the different combinations. So first, you can have shirt 1, then pant 1, shirt 1, then pant 2, shirt 1, then pant 3, and then shirt 1, then pant 4. You're going to keep going with all the different shirts and all the different pants. So then you can do it's shirt 2, and then pant 1, shirt 2, pant 2, shirt 2, pant 3, shirt 2, pant 4, and then shirt 3, pant 1, shirt 3, pant 2, shirt 3, pant 3, and shirt 3, pant 4. Another way you can do this is with a tree. So first thing, you start with a starting point, and then you branch out. So you can either start with the pants or the shirts. So in this case, let's start with the pants. So you have 4 different options for the pants. You can try pant 1, pant 2, pant 3, or pant 4. Then for each pant that you pick, you have 3 options for each pant. So that's either shirt 1, shirt 2, or shirt 3. So this shows all the different combinations. You can have shirt 1 and pant 1, shirt 1 and pant 1, or shirt 3 and pant 1, and so on. You can even switch it. You can say start out with the shirts and then end with the pants. So you have 3 different options for the shirts, and then you have 4 different options for the pants for each shirt. Now another way you can look at this is with a grid. So you put pants on top and shirts on the side. You can even switch this. And so I put all the 4 options for the pants right here, and all the 3 options for the shirts right here. And you can see all the different combinations. Shirt 1, pant 1, shirt 1, pant 2, and so on. And so if you count the amount of combinations, here you got 12. Here, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 12. And then here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 options. Now one more way you can do this is with multiplication. So the only way you can do this is by making sure you're independent. That means that one choice doesn't affect the other. That means that if you pick pant 1, that means you won't picking pant 2. I'm sorry. Okay, so the last way you can do this is with multiplication. So you can just, since you have 3 options for shirts, you're just going to multiply it by the 4 options that you have for pants, and you'll get 12. As you can see right here, you got the 3 options, you have 4 options each, which gives us 12. So now let's look at another example. In how many ways can we form an international commission if we must choose 1 European country from among 6 European countries, 1 Asian country from among 4 Asian countries, 1 North American country from among 3 North American countries, and 1 African country from among 7 African countries. So to do this, you can do any of the following options. You can make a list, you can draw a tree diagram, make a grid, or do multiplication. So to make a list, that's going to take us a really long time because we have so many different factors. Same with the tree diagram. We have so many different factors. So even if we start with the European, we have to keep branching out, and it'll make a huge tree. And same with the grid. The grid might be a little too complicated to do because we have more than just 2 options. So the last thing to do is multiplication. So to do this, I'm going to put a slot for each item I have to pick. So first I need to pick a European country. Then I have to pick from an Asian country. Then I have to pick from a North American country. And finally an African country. And for each option, I have a number of options. So I have 6 European countries to pick from. which I have to pick 1. Next, I have 4 Asian countries to pick from. Then I have 3 North American countries to pick from, and finally 7 African countries to pick from. And if I multiply these all together, I get 504, which is going to be the total number of possibilities. So of course now you can see that it's going to be too big to do for to use a list or to draw a tree diagram. So that's why multiplication works best. And the reason we can do this is because they're independent, which means that one option doesn't affect the other option. So picking a European country doesn't change the fact of picking from an Asian country. For example, if we pick the European country Germany, it doesn't make you it doesn't let you exclude picking another Asian country. So it doesn't mean you can't pick Japan, or you can't pick China, or you can't pick any other Asian country. Now let's look at this example. In how many ways can we form a license plate using only digits 0 through 9 and capital letters other than O and I? Given that each plate has 6 characters, the first of which is a digit and the second of which is a letter. So let's look at the amount of options we have. So first we have a 6-character license plate. So we have 1, 2, 3, 4, 5, 6 slots for either a digit or a letter. Next, it has a condition for us. It says that the first of which has to be a digit. So how many digits are there between 0 and 9? Well, if you count 1 through 9, that's 9, and then if you count 0, 10. So that means we have 10 options for the first digit, for the first character. Next, it says that the second has to be a letter. Now, you'd think, oh, we have 26, but it tells us to exclude O and I. So 26 minus 2, 24. So that means we have 24 options. Now, it doesn't tell us about the rest. That means we can assume that they want either a letter or a digit for the rest of the license plate. So you can do 24 plus 10 to get the total amount of characters you can have. So that means if you have 24 letters and 10 numbers, you have a total of 34 options to pick for the third slot. And same way for the fourth. And same for the next. And for the last option. So that gives us 10 times 24 times 34 times 34 times 34 times 34, which will give us, see right here, 3, 2, 0, 7, 2, 0, 6, 4, 0. So these are a lot of options. 320,720,640 options for the license plate. So in all the previous problems, we were doing combinations. Now let's look at permutations. So a permutation occurs whenever we have to choose several different items, one at a time, from a larger group of items. And this is really important. For permutation, order matters. So if you remember for the other ones, the order of what we picked didn't really matter. If we picked a country, there wasn't any order of the countries we had to pick. But for permutations, the order does matter. So let's look at an example to see how that works. How many different ways can you order 4 different books from left to right on a shelf? So this means that if you start with one book, you can't put that book again in a second or third place. So let's look at what we can do. So what first you can do is draw a tree diagram. And with each tree diagram or each branch, show the order. And you'll have the total number of answers. But since that'll take us some time, let's just do it the multiplication way. Now there's something different. You don't just multiply 4 times 4 times 4 times 4. Because the order of the books matter. Just because you have 4 options doesn't mean you're going to use the same 4 options for each space. So, to explain that, let's look at the first slot where we can put our book. You have 4 different options because you have 4 different books and you can put any book first. So, let's start with 4. Now, after you put one book in that shelf, you only have 3 books left to pick from for the second slot, or the second place right next to the first book. So that means you have 3 options left. Then, after putting the first 2 books, you have 2 books left, and so that means you only have 2 options to put in the third slot. And in the last place, in the fourth slot, you'll only have 1 option left. And it doesn't matter what book it is, as long as it's the last book. So that means we have 4 times 3 times 2 times 1, which is equal to 24 options. So we have 24 ways to order the books. So now we're going to move on to casework. So casework pretty much means that we're going to look at a question and see the different cases, or how many different ways it can be solved. And looking at all the different ways it could be looked at. or solved, as I said. So let's look at this example. The figure represents a road map between 4 villages, labeled A, B, C, and D. The arcs indicate paths between the various villages. How many ways are there to go from A to D, A and D along paths if you can only move left to right? Which means you can only go how the arrows are pointing, from A to B. You can't go from A to B and back to A and then down to C. You can't do that. You can't go back. So first, let's look at the first case. So case 1 says that you can go A to D by going through B, right here. So to see how many different ways you can do this, well, we can look at the different options. So we have 1, 2, 3, 4 different ways to get to B. So now let's look at the following casework problem. How many pairs of positive integers a, b satisfy a squared plus b is less than 24? So for this, I already gave the cases. There's going to be 4 different cases. And to begin, let's just say that each case, we're going to give a value for a. So because we know that a squared has to be between 0 and 24, because 0 squared is 0, and then 1 squared is just 1, and then 4 squared is 16, and 5 squared is 25. So 25 is more than that. We can't do that, and it won't make this true. So it needs to be 24. So that we need them to be between. So that means that for case 1, we can let a equal 1, because if we take the square root of both sides, it just basically means that a can only be between 0 and 4. So a equals 1, then we're going to go to a equals 2, then we're going to go to a equals 3, and then try a equals 4. And those are only 4 cases, because if we try a equals 5, it's more than 24, 25, and it won't work. So with case 1, a equals 1. So if you rearrange the equation to put the b, or put the a on this side, so say b is less than 24 minus a squared, as here, and we plug in the value for a that we're giving, so since we're saying a equals 1, we just do 1 squared, we get it equals to 23. So that means that b has to be less than 23, which gives us the options of b being between 1 to 22. And so if it can be any number between 1 and 22 as long as it satisfies this right here. So you can plug it back in to check if you want, but it'll satisfy the condition right here, which means a squared plus b is going to be less than 24. Next, for case 2, we try a equals 2. So we do the same thing, we rearrange the equation, and we're going to plug in our case for a. So since we're saying that a equals 2, we put 2 squared. So 24 minus 2 squared is going to equal to 20, and that means that b has to be less than 20. So that means that b has 19 options. It can be from anything from 1 to 19, as long as it's less than 20. And for case 3, we have a equals 3. So we do the same thing, same process. We get b is less than 15, which means that we can choose any integer from 1 to 14 to equal b. And for case 4, a equals 4, do the same thing. B is less than 8. We have any integer from 1 to 7. And finally, what we're going to do is add all the options. So since we had 22 options here, 22, plus 19 options here, plus 14 options here, and finally plus 7 options here, which gives us 62 total options. So now let's move on to counting pairs. So let's look at an example. A round-robin tennis tournament consists of each player playing every other player exactly once. Find a formula for the number of matches that will be held during an n-person round-robin tennis tournament where n is greater than or equal to 2. So, This means that we can have any number of players that are greater than or equal to 2 playing each other only once. So first thing we want to do is number the players from 1 through n. So player 1, for example, is going to play player 2, 3, 4, all the way up to player n. And we don't know what n is. N can be anything. And player 2 is going to play player 1 and player 3, 4, 5. So remember, a player can't play themselves. And they can only play every other player exactly once. So this gives us a total of n minus 1 matches for player 1. And for player 2, since we're excluding the 1 right here, because we already included it in this right here, because player 1 plays player 2, we can take away that 1, and then player 2 can't play themselves, so we get n minus 2. And same thing if we have a player 3. So player 3 is going to play not player 1, because we already have that accounted for here, and not player 2, because we already have it accounted for here, and not player 3, because they can't play themselves, but they will play player 4, 5, 6, all the way up to n. So if we calculate that, we can sum it up, the total of matches. So we can do n minus 1 plus n minus 2 plus n minus 3 and keep going all the way till we go down to 2 plus 1. And then we get this right here. N times n minus 1 is divided by 2. And we're dividing by 2 because each match is counted twice. So divided by 2 to get each match only counted once. And so if we let n equal k plus 1, then we can reverse the order. So we'll do with 1, start with 1, then do plus 2, all the way up till we find k. So then that lets us see that k plus 1 times k divided by 2 is going to be equal to the number of matches, or the number of matches that will be fought for an n-person round-robin tournament where n is greater than or equal to 2. So using what we know about counting pairs, we can figure out a formula to find how many diagonals are in a polygon. So first, we can just draw polygons and then draw the diagonals and just count them. For example, a triangle has 0 because whatever they're connected to, the vertices that are connected are already connected as diagonals. A quadrilateral, like a rectangle, has two diagonals. And the pentagon has 1, 2, 3, 4, 5, 6, and a hexagon has 9. So, if we check right here, we can use this equation right here. And the way we figure this out is by saying that there are n vertices in a polygon, and that vertex is going to connect to n minus 1 vertices. But 2 of those vertices that it's connected to is going to be the side of the polygon. So, as you can see right here, this diagonal is going to be connect right here, but then 2 of these are going to be the sides. So, and we don't count that. So I'm going to say n minus 1, because n minus 1 we already accounted for the first diagonal, and then minus 2 because of the 2 sides that it's connecting, which is going to give us n minus 3. And because each polygon has n number of vertices, we can say that n times n minus 3 is going to give us that. Then we're going to divide it by 2 because we don't want to count each diagonal twice. Like we don't want to count this diagonal and this diagonal. So we're going to divide by 2 so we don't account for each diagonal twice. And that gives us our equation. Alright, so now let's look at our last section, probability. So, if all outcomes, which are end results of a situation or a circumstance that happens, so if all outcomes are equally likely, then probability P is going to be equal the number of successful outcomes over the number of possible outcomes. So, for all of our questions here, we're going to make sure that we assume that all the outcomes are equally likely. That means that, for example, if we flip a coin, there's only a 50-50% chance of heads or tails. There's not a 60-40 or 20-80. It doesn't mean that one side is going to always do more or happen more than the other side. So that's what we mean by equally likely. So, and also really important to remember is that probability is always going to be a fraction or a decimal that is going to be either greater than or equal to 1 or less than or equal to 1 or greater than or equal to 0. So, now moving on. Since we talked about coins, let's look at an example about coins. Probability of a flipped coin. So what is the probability of a flipped coin facing heads? So if we flip a coin, what's the probability that it's going to be heads? So, first I want to look at the possible outcomes that can happen. Well, it's a coin, so it only has 2 faces. You can either face heads or tails. So you have 2 outcomes that are possible, which means we'll put 2 on the denominator. Then we have to look at the successful outcomes, or the outcomes that we want to happen, or that we plan on happening, or that we know that are going to happen. So the outcome that we want is just a heads, as it's asking, coin facing heads. So we're going to put 1, since there's only one outcome. So we put 1 over 2, which is equal to 0.5, which is our probability. Now let's look at a question with dice. So what is the probability of an odd number facing up on a fair dice? So on a fair die, that means that all the faces have an equal chance of rolling. And if you don't know, a die has 6 sides, numbered from 1 to 6. So it has 1, 2, 3, 4, 5, 6. 6 faces. So, looking at the possible outcomes, you can have any of those numbers. You can have 1, 2, 3, 4, or 5, 6 face up. And looking at the successful outcomes, or the outcome that we want, which is an odd number, we only want 1, 3, or 5. So, we're going to put this into our equation right here. So probability is going to equal 3 over 6, because we have 3 successful outcomes, or the outcomes that we want, over 6 possible outcomes that could happen. So 3 over 6, which simplifies to 1/2, which is equal to 0.5. And you can put probability as either a fraction or a decimal, as long as it's simplified. So here are some common things or type of probability devices that are used in probability questions. So the most common are usually cards, die or dice, so dice is the plural of die, and coins. So for cards, here's some information that will be really useful when you're dealing with these types of questions. So any question that has cards, always remember that there are 52 cards in a deck, and 26 of them are black, and 26 of them are red. And of the 26 that are black, 13 of them are spades, and then 13 of them are clubs. And for the 26 that are red, you have 13 that are hearts and 13 that are diamonds. Also, a really important thing to note is that in each of these 4, there is going to be a suit. So there's always going to be a king, a queen, a jack, and an ace of spades, which is equal to just a 1. And then after that, they'll have all the numbers from 2 all the way till 10. And same thing with the red. So it's going to be for all of them. Next, look at die and dice. So a die is just a single die, and then dice are 2 dice. And so always remember that there are 6 sides, and they'll be numbered from 1 to 6. And usually they'll have dots. So they'll have 1 dot on one side, and then 2 dots on the other side, and then 3 dots, 4 dots, 5 dots, so on. And next thing for coins, always know that there are usually 2 sides, and when you flip a coin, there's only 2 outcomes. You can either have heads or tails. Thank you so much for watching, and I really hope you enjoyed and learned a lot. And please don't forget to subscribe. Thank you.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!